Yes, so what if the bases are actually different? So let's look at another example in which the bases are different, and then we see what's going to happen. So if we have something like 4 exponent 8, and we want to multiply that by 3 exponent maybe 2. There's actually no law in indices that we can use to solve this, because the bases are not the same. The law says that if the bases are the same, you maintain one of the bases and then you add the exponent. We have exponents here, all right. But since the bases are different, we wouldn't even know which of the bases to write here. So because of that, we don't apply indices to something like this. I mean, there's no single law in indices which can be used to solve this, unless maybe we press the answer for this independently, and if the answer is A, we write it here. We also consider this, which is 9. So 9 is, so the answer for A, we just multiply that by 9, then we need to solve this. So what if we have a situation whereby the numbers are being divided? So we have something like A exponent m, not multiplying this time around, but rather being divided by A exponent n. What is actually going to happen in this case? So we are still going to maintain one of the bases anyway, but since they are dividing, we are going to subtract. And for the subtraction, we have to be very careful. We are actually going to subtract this from this. That's what we do. We subtract n from m, and that will be written as n minus n. If you write it as A exponent n minus n, this is very, very wrong. So it's rather the first exponent minus, then you bring the second exponent. So let's take a typical example of this. So we can have something like 2 exponent 8 is being divided by, let's say 2 exponent 3. So the answer is going to be, you maintain one of the bases, then 8 minus 3. And 8 minus 3, if I'm right, should be 5. So it should be 2 exponent 5. So when you take your calculator, you press 2 exponent 8 divided by, you press 2 exponent 3. The answer you will get should be the same as 2 with the exponent of 5. That's what this law means. So let's see another example in which we have some form of negative exponents. So that would be maybe 2 exponent negative 8 divided by 2 exponent maybe 2. We are going to actually apply the same way. So still 2 negative 8 minus 2. That's going to be 2 exponent negative 10. So the answer for 2 exponent negative 10 is actually the same as 2 exponent negative 8 divided by 2 exponent 2. So this is how we are actually going to do it. Let's also take another example. What if we have something like 2 exponent negative 8 divided by 2 exponent negative 2? You can pause the video over here, you take your book and pen, and then you try solving this. Okay, let's do it together. So that's going to be 2 exponent negative 8. This minus sign here is for the 2. So you have to bring the actual negative sign. Then this is also negative 2. So you write negative 2. So we are going to have 2 exponent negative 8. Negative negative is going to give positive. So positive 2. That's also going to give us 2 exponent negative 6. What this means is that the answer for 2 exponent negative 6 is actually the same as this. So you can try that on your calculator. Yes. Okay. I think I've been cleaning these things very fast. I'll take my time with the cleaning, okay? I'll take my time with the cleaning so that I don't clean very fast. Okay, so what if we have something like A exponent n, and then there's also a number n multiplying as an exponent multiplying this n. How are we going to solve this? We can actually bring in the n and then we take out the n. We can do that. So this is also the same as A exponent n. This is actually the same as that, which is also the same as A exponent n multiplied by n. This is also true. And due to commutativity, this is also the same as A exponent n times n. No, commutativity tells us that if you have n times n, even if you change the positions of m and n, you are still supposed to get the same answer. That's what commutativity tells us. So all of these are the same. And let's take a typical example of this. So we have something like 2 exponent 3, 2 outside. We can bring in these 2, then we take out the 3, which is also the same as 2 exponent 2 times 3. And this will also be the same as 2 exponent 3 times 2. 3 times 2 is 6. Okay, so 2 exponent 6. So the answer for 2 exponent 6, which is at the right hand side, should actually be the same as the answer for this, which is at the left hand side. So this is what basically indices is about. Okay, so this what we just looked at are the laws of indices. Let's look at a few properties of indices, and then we can actually begin solving questions on indices. So let's look at that very fast. So let's look at the properties of indices. So the properties of indices are actually some other things we need to know in addition to the laws that we've actually studied of indices, and these are what is going to help us to be able to solve so many other questions. Okay, so one property of indices is actually telling us that if we have a number a with a negative exponent, so a exponent -1, the one property of indices says that this is the same as 1 divided by a. But a can't be equal to 0. Okay, a can't be equal to 0. If a becomes 0, this law doesn't apply. So we usually say that any number exponent. Okay, okay, so a can be equal to 0. Okay, so let's take an example. We can have something like 4 exponent -1. So 4 exponent -1 is actually the same as 1 divided by 4. Okay, we can also have maybe 5 exponent -2. So if we have something like 5 exponent -2, what we are going to do first of all is that it's going to, because of the negative sign here, it's still going to be 1 over, but then it will be 5 exponent 2. It doesn't mean that we are going to write these 2 at the top here. No, that's not what it is. Due to the negative exponent, you write 1 here, then over 5 squared, which is the same as 1 over 25. So 1 over 25, the answer for 1 over 25 is the same as that of 5 exponents -2. Okay, let's take a last one on this. So we can try another one, maybe 6 exponents -8. So 6 exponent -8 is going to be 1 over 6 exponents 8. So when you take your calculator, you find the answer for 6 exponent -1 over 6 exponent 8, and then you compare the answer to 6 exponent -8, and then we check whether the answers are actually going to be the same. Okay? So this is one of the properties of indices. Let's look at a second property. A second property tells us that any number, let's take a variable a. So any number like a, exponent 0 should be equal to 1. Okay, any number that's like a with the exponent of 0 should be equal to 1. So let's see if we can prove that this is actually the case, that any number exponent 0 is equal to 1. So let's take something like a exponent n. So let's say the proof. So we want to be able to prove that any number exponent 0 should be equal to 1. That's what we are about to do. So let's take a exponent n divided by a exponent n. Okay, so we know that this a exponent n can cancel this one, this can cancel this. Okay, so a exponent n divided by a exponent n, the answer should be 1, right? Because a exponent n can cancel itself 1, and it can also cancel the denominator 1. So, but we want to apply indices here. We know that whenever they are dividing, we can rewrite this like this: a exponent n divided by a exponent -1 to be equal to 1. And from indices, we said that when the bases are the same, then we are dividing them like this. We have to subtract the exponents, right? So this is going to be a exponent n minus n, right? Equal 1. And any number by itself, usually, any number subtracted from itself should be equal to 0, if I'm right. And I know I'm right anyway. So A exponent n minus n is going to be equal to 0, and then you are going to get this to be equal to 1. So, good. So this is the proof that any number exponent 0 should actually be equal to 1. You know, in mathematics, if you're able to prove something like this, you actually become so happy. So you can add something like a smiley here to show that you are happy anyway. Okay, so this is one of the laws, one of the properties of indices that we are also looking at. So from here, let's see if we can move straight to solving questions on indices. So I want to clean this side in order to create space.